Okay, this is Chapter 2, Part 2, and we're going to do a quick overview of the atom. And if you remember, the atom is the smallest unit of matter that still retains the properties of an element. So you can split an atom, but it no longer retains the properties of that element. But atoms are made up of particles, and the three particles that we're going to talk about are neutrons, protons, and electrons. And I'm sure everybody already knows this, is neutrons are neutral charge. They don't have a charge. And protons are positive, and electrons are negative. So, neutral, positive, negative. So it makes sense that for a neutral atom, you're going to have the same number of positive charges as you would negative charges. So the number of protons and the number of electrons will be equal if the atom is neutral. Makes sense. So hopefully we also remember that neutrons and protons reside in the center of the atom. We call that the atomic nucleus. And electrons are outside of the nucleus in a kind of a cloud that goes around the nucleus. They do not, though, orbit the nucleus like the planets around the sun. That is not the way they move. We call their states orbitals, but it is not like a planet around the sun. Another thing to note is that when we are measuring the mass of an atom or of its particles, we measure them in daltons, or we can also call that atomic mass units, and we'll come back to that later. So remember, protons and neutrons are in the center, and so remind yourself which one was positive, and I'm hoping everybody's saying the positive one was protons, and the neutral one was neutron. And here's the electrons, negative, outside of the nucleus. So a quick little question to see if everybody's paying attention. Electrons, true or false, are they found in the nucleus? So think about that for a second, and I'm hoping that everybody is thinking about this and saying that they are not found in the nucleus. That is false. They are found outside of the nucleus. So I'm hoping everybody is familiar with the periodic table. And if you remember with the periodic table, you have a number on the top. So say for carbon, that would be 6, and a number on the bottom. So which number is the atomic number? Remembering that the atomic number is the number of protons. Hoping everybody said the top number, the smaller number, is the number of protons. And the number of protons is equal to what other particle? Hoping everybody is saying that is also equal to the number of electrons. Then still thinking about the, oops, go back here. Still thinking about carbon here. So if we know that the atomic number is the top one, then the mass number is going to be the one at the bottom. So for carbon, the mass number is going to be 12. So what does the mass number mean? It means if you think about let's go to the next slide here, what particles actually have measurable weight? And that is protons and neutrons. Each of them weigh about 1 Dalton. Electrons, very, very small weight, very, very, very low. So if you have the mass number, that is going to be the number of protons plus the number of neutrons is going to be the mass number. The atomic mass, the difference between that is the atomic mass is the actual mass of the atom, whereas the mass number is an approximation of it, very close approximation, and just by the number of protons plus the number of neutrons is equal to the mass number. So when we look at carbon here again, then the mass number is the number of protons plus the number of neutrons, and that's going to be the mass number, which is going to be 12. And how many protons did we say there were? We know that from the top number. So we know the number of protons is going to be 6, plus the number of neutrons is going to be equal to 12. Very simple math. You can get the number of neutrons is equal to 12 minus 6. So the number of neutrons is equal to 6. Very, very easy. You get the number of neutrons by taking the atomic number, the top number, and subtracting it from the the mass number. So pretty easy. In our next section, we're going to go over isotopes and finish up the atom.